Okay, ladies and gentlemen, good morning to you all. I hope you're doing well. Let's see, is this 241 with the video online? Yes, it is. Yes, it is. Now, here's what I'm going to introduce to you guys today. We've been graphing trig functions. And if I go to my website, let's take a look. Oop, not 261, 241. And here we go. We're going to introduce you guys a topic known as phase shift. Okay, so we're still graphing trig functions, but now we have something called phase shift. So you do want to keep up with your homework, because if you don't and you think you're going to study this the night before, ladies and gentlemen, that is not the way to study math and be successful at anything. Okay, so don't do that. And I'm going to put this worksheet in the comment section, but I want you guys to see that we've introduced something known as a phase what? A phase shifting here. All right, so you have these equations that look like this. I already see a little typo, that A, really odd. Anyway, let's try to import this into Notability. That we do know. Okay. So phase shift. You say, what in the world is phase shift? Let me get out another color. I'm going to try to remember. I'm going to use maybe green. I don't think we've been using green. You see this value here for sine and cosine? That letter B is known as your phase shift. Okay, so again, we have A, these A values. K is still there. K is always positive. And so everything is very similar, meaning your amplitude is the absolute value of A, and then we have the period here. Your period is 2 pi over what? Over K. All right? Now, you might say, okay, but what is new? What's also new here, ladies and gentlemen, is this. What's this? The interval of one cycle will actually be different. In other words, you start at B, and then you end where? At B plus P over here, okay? So let me kind of, if you guys want to really see things in terms of colors, this is the effect. And I guess our phase shift is not purple, phase shift is green. So that B value, ladies and gentlemen, the phase shift value, is where you start, and then you take the phase shift and you add the period. And that, ladies and gentlemen, is new here. Okay, so what is new is we're adding a phase shift, which is really a horizontal shifting. You shift the curve horizontal. What is horizontal? Do you guys know what horizontal is? That's moving the curve how? Left or right? It's a horizontal shift, left or right. Okay, and so we have this x minus b, x minus b. So amplitude, phase shift is B, ladies and gentlemen, and it's a horizontal shifting. You're going to see my point here. Okay, so what I'm going to do here is, since you guys have the evens, I'm going to start with the odds here, because on the video, I believe I started with the odds. Now, take a look at this question here, number 1, okay? This is kind of one of the simplest questions, but you're going to have arithmetic today. So there's arithmetic involved here. All right, so let me express this to you. This is kind of an important feature, okay? People sometimes have trouble reading what the phase shift is. You say, what are you talking about reading the phase shift? Yeah, they have trouble reading the phase shift. So let me share with you guys how you do it, okay? What number comes after this minus sign? It has to come after that minus sign. Here. What comes after? Phase shift what? Is that B value. So this is x minus, and x minus. The B value is not here. It comes after the minus sign. That is what B is. Say that again. The B value comes how? After the what? Minus. After the minus sign. That's B. So you say, okay, what came after the minus sign here? Yes. So ladies and gentlemen, you want to know what your phase shift is here? Phase shift here will be pi over 4. I got to scroll out, I guess, to write that, okay? So this here is what you guys want to what? See. Your phase shift is going to be after the minus sign for question 1. I'm not going to do question 2 here, but I want to illustrate something here, okay? You see that phase shift here now? The B value, ladies and gentlemen? What came after the minus sign? Pi over 3. Good. So if you guys get stuck or you get confused, we have these videos. B is pi over what? 3. All right, you guys okay with that? Now, here we go. This is what I'm saying to people. People get it here. They go, okay, B comes after the what? The minus sign. I understand here with these B's now. You go, okay, Mr. Judge, I get it. B comes after that. Okay, fine. But then they see this plus, and they get confused. You guys with me on that? So when people see the plus and you say, well, what does that even mean then? Well, ladies and gentlemen, how do you handle that if there's plus? Do you guys know what's going on here? What does that mean here? I do it this way. I say to people, focus on this, okay? Isn't it true that what you see here can be written as x minus the minus? Pi over 3, I'm saying focus on what you guys see here. You say x minus the minus. Why can I say that's minus the minus? What am I saying here? This would be what? Minus the minus is what? Is plus. All right, you guys okay with that? Now, could you guys tell me what comes after the minus sign? What's my B now? Did you guys see it? Negative pi over 3. So B could be negative. That, ladies and gentlemen, students look at that and that's when they get, whoa, wait a minute. Because you got to go back to pre-algebra You guys know what I mean? Pre-algebra. What happened in pre-algebra? What's a negative times a negative? So a negative here times a negative is a positive. So there you go, ladies and gentlemen. B is negative pi over 3. Easy peasy, lemon wet squeezy. Okay? And because you go, but Mr. Judge, in the graphing format, x minus, I don't see a plus. And I say, go back to pre-algebra. Minus the minus is what? Plus. Okay? You say, is it? Yeah, go back. Think about this, right? What's negative, if I said to you, what's negative 3 times negative 2? Negative 6. What's negative 1 times negative 1? Positive 1. Is that true? Because the minus is sorry, that's not negative 6. It's positive 6. So negative 3 times negative 2 is positive 6. Negative 1 times negative 1 is positive 1. Minus the minus makes this a nice what? Plus. And that's what's happening, okay? So you can get the phase shift when there's an addition sign here. And you say, well, how do I get that phase shift again? Well, write this as x minus a negative what? Pi over 4. Where is this negative sign? Right there. You guys okay with that? What does it mean about your B value? B value is negative what? Pi over 4. Easy peasy lemon squeezy. Okay, and then you say, okay, well, look at number 5 then. You go, what's going on with number 5 here? Well, number 5 has a lot going on. Focus on this here now. Okay? First of all, what is this? I colored it purple. Why? What is that? Isn't that K? Is that true right in here? If you see a K there out there in front? So that's the same K you guys use in your what? Period. So if we look at this, you might first start off and say, hey, is it true my K value equals 2? The answer is yes. Now, what is the phase shift going to be? Can you guys tell me the phase shift? Well, isn't that portion again going to be the following, right? That portion is x minus a minus pi over what? 2. Is that true? Because it has a plus there. You guys see the x plus pi over 2? So that's minus the minus. Okay. So here's that minus sign. What is your phase shift? The phase shift of B is what? What's B? Negative pi over 2. You guys okay with that? All right. Easy peasy, lemon squeezy. You guys know how to read this? Is that a big deal, how to read? Yes. Read the graphing format. What are you guys going to tell me about the next one? What about these, okay? We're reading this. What's my K value in purple? What's K here? Is K going to be what, 3? Is that true? K equals what? 3. And then we have x minus. What always comes after the minus sign? What always comes after? B, the phase shift. So what's the phase shift going to be now? Anybody tell me? It's pi over 4. Isn't that a positive pi over 4? You guys see my point? Isn't it opposite? So sometimes people look at this and they just refuse to remember a negative times a negative is a positive. So this b here is pi over 4. All right. Does that sound like it's okay for you guys? Do you need all of these values? Yes. You're going to need these values. All right, let's go to the next one. Let's go to 7 here. First of all, when I read this, in terms of the colors, what is this? Isn't that my A value? Is that A, ladies and gentlemen? What's the value of that little A? If I try to sneak it in here, okay? I'm going to say here, A is going to be 3. You guys okay with that? Okay. What is K? It's K2? Okay. Now what is B? B always comes after the what? That minus sign. There's my B. B is pi. Okay? So I get B being pi. So I'm going to get my colors out. What do you guys think? Can you guys read the... Can you guys read this? I haven't even showed you guys how to use it because we first have to show you how to read the values. Okay, you guys okay with that? Now let's see if you're really awake. Uh-oh. Let's close the door before I get scared. I'm not even awake yet. That'll wake you up. I guess that's the whole idea. A little OCD in my part, I guess. I used to be in the Marines. I think I have a little OCD. I'll get startled when I hear screaming. Huh? Is it? I'm sorry, not OCD, PTSD. See, I told you I'm not awake. I'm not awake. I'm not even awake. I could read this in my sleep. Anyway, okay, let's see if you guys are awake. Hopefully you guys are awake. There's no number there. Is that true? And I just put a number 1. It looks like a line. What does that mean? A, good, you guys know that by now. A is 1. So working on your homework, you guys know A is 1 here. Is that true? And so here as well, we should say there's a 1 there. You can always put a 1 in front of any number. Because 1 times anything is always itself. So this means A is 1. This means A is 1 here. And then here, I can always put a 1 in front of any number. Is that right? 1, 1. A is 1. What's this? A is 1. Here's a what? Can you guys see a 1 in front of all those numbers? Okay. So that hasn't changed. That's new. Is that true? You guys with me on that? That hasn't changed. So we can see what's here. Now, let me ask you a question here. Go back to the first one. What is K? Because if we look at the graphing format, you say there's a K in front of the signs inside there. You see the K value? So what would K be for question 1? Also the same. You say, hey, can I put a 1 here too? Yes, let me go back and do that. I can put a 1 there as well. Now that one is not A because it's in front of that X. It's between the sign there, right? So K here is what? 1. You guys with me on that? So I'm going to move this here, and I'm going to put the K as 1. Yeah, thanks. Yeah, but you do have this. Yeah. What's K over here now? Could put a 1 there. K equals what? 1. Okay, you guys see that here? And the same thing is happening where? Here. Oops. Put it in purple, but there. K here equals what? 1. K is 1. Oh my God, look at all those colors. Let's do a few more, is that right? Anybody have any questions on all those K values, by the way? You can see that there. What about this? Let's read it left to right. What's my A value now? A here will be what? I guess I'll put it, well, we'll move it back down over here so people can see that consistency. Okay, A here is 3. What's A going to be now? What's your A value? You guys have to read it. I'm looking at number 8. What's A? Yeah. A is 2. Here's a K. K is what? 4. Okay. Now, what is our B value? Doesn't it come after the what? Minus sign? What's the phase shift? Pi. Good. Is that positive pi? Yes. What's A here? Isn't that 3/2? What's K? K is what? 4. Is that true? Okay, if you're really awake, tell me what B is. Anybody know? What's B? Negative pi over what? 3. Good. Easy peasy lemon squeezy. So if you have to, and some students do, if you have to see it, because you have a plus and you write that plus as minus and minus, if you have to see that, then that's fine. You just say, okay, minus the what? And there's your B value, okay? So if you have to do that, that's fine. Okay? Because I used to have to do that when I was a student looking at this. And, you guys can do the rest here. But here's my point to you guys. We want to graph using these tools now. So to graph number 1, okay, to share with you guys what that looks like. Yeah. All right, I'll put it over here. Okay. They say graph y equals sine x minus pi over 3. We got all those values again. We knew a was 1. We knew k is 1. And we know that the phase shift is pi over what? 3. So here's the phase shift. Now, remember, what's the period here? What's our period going to be? Period equals what? 2 pi over k, where k is what? So 2 pi over 1 is just simply 2 what? 2 pi. Okay. The amplitude, we forgot to do that. What's our amplitude going to be? Let's start with the amplitude first. Let's go always systemically. Amplitude. Absolute value 1, 1. So our amplitude is going to be what? 1. All right. Easy peasy lemon squeezy, right? So what do you guys need to find again? I'm going to put this here, and I'm going to circle it in red. You're going to need to find the interval of one cycle. So always remember what the definition of the interval of one cycle would be. It's going to be the what? B and B plus P. So this is where there's going to be some addition here, ladies and gentlemen. So this is going to be an important thing to find. Okay, this is your interval of one cycle again. And that's where the addition is going to be. So you got to put the B value here, here, and then you add the period to the second B value, because this again here is where you what? Start, and then this is where you what? End. So what is your phase shift going to be? Pi over 3. Then now I have pi over 3 now, plus the period of what? 2 pi. So ladies and gentlemen, here starts our career with arithmetic. Because this is where people need to what? Focus. Pi over 3 plus what? 2 pi. Okay. So can I ask you guys that question? How do we add? You have to have the same common denominator, right? So you say pi over 3 plus 2 pi. Well, you can only add two fractions, so convert this to a what? Fraction. You guys remember that? Now, here's that secret. You see the denominator is 3? You see, I can only add again fractions with the same denominator. So I'm going to use the algorithm here so everybody can remember the algorithm. This is with the same what? Denominator. Here's the whole point. If I have the same denominator, I am free to add my numerators. There it is. Okay, you guys with me on that? That's our game plan right there. But you might say, Mr. Judge, I don't have a 3 down there. I have a 1. Well, how do you guys get a 3? Multiply the top by 3 and the what? Bottom by 3. You guys remember this? Is that true? Like, darn those fractions. This is actually adding fractions. A whole number with a fraction. And now what is 3 times 2 pi? What is 3 times 1? Don't you have the same denominator now? Is that right? You have the same denominator? Now, what does that mean? What do I do now? Pi plus 6 pi divided by 3 gives you what? 7 pi divided by 3. There it is. So you say, do I replace this with 7 pi over 3? The answer is what? Yes. Now, it's in your notes. It's in the video. But the point I'm making is, to get the interval in one cycle, you need to do some arithmetic. It's arithmetic with fractions. Okay, do you guys remember that? I showed you guys that video yesterday. Okay, no, say go back, Mr. Judge. You go. How do I find arithmetic with fractions here? Well, we're going to get out of trig. Let's go back to trig. We're going to go to what's course here? Math 115, worksheets and videos. Adding fractions, algebra lecture 2. You guys see that young Mr. Judge there? That was all pre-iPad. This is a video. The board was dirty. It was a whole thing. It was in the bungalows. Part of it was in the technology building. Part of it was in the bungalows. I had a really nice student. He used to do car detailing, and he used to actually clean the board for me because he knew I was videotaping. I remember him vividly. And you want to know something? I even recorded videos for pre-algebra. And you want to know what happened? Because the board was so clean, the camera lost focus. It was too bright. The board was bright, and so the camera couldn't focus on the board. So I have all these pre-algebra videos that are out of focus. It broke my heart. I said, oh my God, really? Really? Well, they took those courses away. They said it's a whole thing, ladies and gentlemen. Oh my God. They took all those courses. They said, no, we don't want to teach these courses. What they don't want to do is pay to teach those courses. That's what they don't want to do. So they say, hey, you know what? Tell students, go get the tutoring. Go over, give you a little extra time in a trig class. Go over a little bit of this arithmetic there. Do a little bit of that, and then, but you can't give homework on that arithmetic, you know. So I can even show you this, but I can't give you homework on it. And these are people who have never taught math in their life making decisions about how math should be done. And the bottom line is really they just don't want to pay for remedial education. You say, well, what happened to those students? Well, the legislators even told me, we know some people are going to get hurt. Are you serious? So a young Mr. Judge who started in geometry, that kid who came here They don't believe he can even finish or do it. They don't even want to bother. That's the truth. Because they don't want to pay for some of those courses. They say, it'll take students too long to get through. You say, well, doesn't matter where you start. It matters where you end. It's where you end, not where you start. Because by their definition, I would be a failure. I wasn't out in 2 years. You know how long it took me to go to ELAC as a night student? 4 years. So by their definition, I'm a failure. Let's make sure the audio's on. Maybe it's best that the audio's not on. What? No, it's recording. So, true story, ladies and gentlemen. It breaks my heart. So I'm really heartbroken that pre-algebra videos are not there now. Now I'm really, really like, oh my God. And sometimes I run across the files when I'm looking for files, and I'm like, I remember I recorded all these, and the board was so clean because that nice student, the camera went out of focus. So some of these boards that you see are kind of dirty, but it has that contrast, I guess, for the sensor and the camera. And yeah, that's the story behind it. But hey, nevertheless, you got adding fractions here. You got the worksheet. You got the video solutions. You got the lecture, combining like terms. You got the algebra here, solving linear equations. I remember those days, ladies and gentlemen. Back in those bungalows, I'm telling you, those were the days. We didn't have all this fancy equipment and computer and stuff like that, you know. But it was amazing anyway. That's what I think. We didn't have all this stuff. But now I'm on the iPad. So I just want to go back and share with you guys these resources because that's what they're saying. Hey, have students go get these tutorings, blah, 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 whatever. So anyway. But that's the whole idea behind adding fractions with different denominators. And then a pi plus 6 pi is 7 pi. That's combining like terms. So, you know, it's all used. And we're going to be using this arithmetic. You say, why? Because remember, where do you start in this graph? You start here. Where do you end? Here. So, on your real number line now, and we say, well, okay, let's graph this. Yeah. So I'm just going to kind of do it a little bit. I'm going to go for a wider spacing today. Okay, what's the amplitude again here? Isn't it 1? So we're going to put the spacing on this correctly. Here's 1 and here's -1. Here's your x-axis. Here's your y-axis. And where do you guys start again? We start where? Pi over 3. And where do we end? 7 pi over 3. So that's a positive number. So now this is the phase shift, ladies and gentlemen. You start at pi over 3 and then you end where? Okay, that's the significance of getting that interval of 1 cycle. This is why you guys do it. All right. What curve is this? This is going to be the sine curve, right? So how does sine behave, if you guys remember? Okay. Let me go through some more detail. I need that middle value. I need these other middle values. But sine starts on the x-axis. Is that right? And then it goes to the highest value up here. It comes down to the x-axis at an intercept. It goes down to that negative value. And then it comes back to the x-axis, ladies and gentlemen. This is the sine curve. So essentially, you have the curve. All right, you guys with me on that? Essentially, you're kind of done. You say, what do you mean I'm done? Well, you're not exactly done, because they're going to want to know, where are the x-intercepts? Remember, we're asking you that question? Where's one x-intercept? At x is what? Pi over 3. Where's another x-intercept? At x is what? 7 pi over 3. Here, here. Where else? There. I'm missing an x-intercept value. Do you guys know what I'm saying? So how do I get that x-intercept? Good job. You add them and you what? Divide by 2. Good. Thank you for remembering that. See what I'm saying? Hard work pays off. Pi over 3 plus what? 7 pi over 3 divided by 2. What's pi over 3 plus 7 pi over 3? 8 pi over 3 divided by 2. And then we have what? 8 pi over 3 divided by 2. And then 8 pi over 3 times what? 1/2. So when you multiply your fractions, you say, is there another algorithm we do? Yeah, remember I gave that to you guys the other day? How do you multiply fractions? I'm going to give you an algorithm. A over B times what? C over D. What did I give you guys the other day? It's what? A times C over B times D. So you're now going to get what? I can say, you say, Mr. Judge, is 8 pi times 1 over 3 times 2? Yes, what happens here? 2 goes into 8 how many times? 4. So what does that give you here? Is that 4 pi divided by what? 3? Yes. Why is that 4 pi divided by 3? You got 4 pi over 3. That is the intercept. Yep. Yes, and that's what we did. 8 pi over 6, yes. Absolutely. It is 8 pi over 6. And then, yes, you reduce the fraction. It will become 4 pi over 3. Absolutely. Yes. Because remember, what is that 8? If you guys remember back in those days, 8 is 2 times 2 times 2. 6 is 2 times 3. You cancel the 2's. This is what I used to teach back in the day. Back in the good old days. And that's why it's 4 pi over 3. So, ladies and gentlemen, you now have the missing what? X-intercept, which is going to be 4 pi over what? 3. There's your x-intercepts. So how do you guys get the maximum value now? Right? Let me go back. Can I erase all this work? You guys have that in your notes? Maybe not. Maybe we'll say, okay, remember, what's the maximum value? That's the highest value of this. It's the amplitude. The maximum value is 1. And that happens for what x value? Happens over here. For x is what? Yes. You're going to have to find what again? What's midway between pi over 3 and what? 4 pi over 3. Okay, the midway. Let me go back. Midway, I'm going to erase this because now we have another arithmetic question. That's what I'm saying, arithmetic. So pi over 3 plus 4 pi over 3 divided by what? 2. What does that give you? 5 pi over 3 divided by 2. Okay, how do we write that? Do you guys remember? If I'll do the horizontal because I'll forget. 5 pi over 3 times 1/2. I then use this algorithm again. That's why I kept it there, right? Multiply, and then what? Multiply. 5 pi over what? 6. That goes here. So that happens when x is what? 5 pi over 6, the maximum value. That's what we're looking for. Easy peasy lemon squeezy. Yeah, it doesn't work with the phase shift. It doesn't work as easily with the phase shift. Yeah. So, because I would show you if it did. You know, so there you go. The minimum value now, you go, hey, what's the minimum value? Well, the minimum value, if I write it here, is what again? Isn't that -1 down over here? Right? Minimum value. That happens for what x value? So you might say, I don't know what x value. I don't know either, but I do know this. It is midway between what? 4 pi over 3 and 7 pi over 3. It's midway between 4 pi over 3 and 7 pi over 3. Okay, so what do? 4 pi over 3 plus 7 pi over 3 over what? Over 2. Which gives you 11 pi over 3 over 2, which is 11 pi over 3 divided by 2. 11 pi over 3 times 1/2, which is 11 pi over 6. There we go. Easy peasy lemon what? Squeezy. That's the arithmetic that we have to do on this. So, all right. So that happens when x is 11 pi over what? 6. So remember, the whole idea behind graphing isn't that you got nothing better to do. The whole idea is that you want to know physically the attributes of a graph, because in science courses, we use the attributes of this graph. We use the x-intercepts. We use the minimum and maximum values. It's used. That's why you got to find them. And that's why you need the arithmetic for it. So this is called a horizontal shifting, that your sine curve shifted to the what? To the right. How many units? Pi over 3 units. That's the phase shift value. You know, people say, can you show me that in Desmos? Well, what function is that? And this is going to be sine what? X minus pi over 3, right? So just to kind of demonstrate that idea of shifting here. I'll get rid of all of our past graphs. x minus, I have to spell out pi divided by 3. And again, we got to give that interval of 1 cycle. I mean, generally speaking, though, this is, again, I could do it in general. Let me show you guys the general idea. Okay? This is infinitely many cycles. So notice the purple sine curve. And then, what did they do? They shifted this sine curve how many units? Pi over 3. You guys see it right there? This is not one cycle. This is infinitely many cycles because it's periodic. But you guys are seeing the effect of the sign of the shifting here. It's shifting it horizontally every point to the right by pi over 3 units. If I really wanted to look at that interval of 1 cycle, to really look at the graph that we have, although it's not necessary, but it's fun. There's pi. And I think it was 7 pi over 3. We can see the specifics now. That green is the phase shift. So I'm going to put that in our there it is. Okay, that's exactly what we are talking about, folks. A phase shift, meaning horizontal shift. That's a picture of your pi over 3 phase shift. Easy peasy lemon squeezy. Yes? Say it again.
Well, sometimes when I'm doing the homework and trying to graph, I'm not sure if I'm supposed to make the curves larger or smaller.
Oh, for graphs has to be scale.
Yeah.
It's just a sketch. Just a sketch. Don't go into that detail. You got enough work to do. Maybe that's like a high school thing. You know, high school, you had a whole hour, you sat there and you compared amplitude 1 and 2 and 3. You had to draw it to scale. Right. Notice we're just sketching. And yeah, you know, the important thing is that you guys know these points. You know, if I even went back to that green curve in Desmos, you know, it's like I keep saying that. Let's go back to the green curve, right? You have this special point, that special point, this special point, this special point, all those points. Let's import that one. Right? My point to you guys with everything we're looking for, notice that location here. Okay? Those are the x-intercepts. This is where we did our arithmetic. Is that right? And then 5 pi over 6, 11 pi over 6, is that we have the maximum value of 1, we have the minimum value of -1. So go back. It's exactly the work we did here. So compare and contrast. An easy way for you guys, if you worked on that homework even, and you did this process, would even be to even check in Desmos, doing exactly what I just did. I just touched those important points. And, you know, when I work on some of those, I already worked on the odd or even numbers. Maybe work on the odds and show people these important points. You guys can get that. But the real issue will be in the arithmetic. Okay. Anyway. So what's the other one? So now let's say, okay, let's look at another one here, okay? All the detail. You say y equals what? Cosine x plus what? Pi over 3. Okay, we already have that information, don't we? So what is, we have this. Let's go back. The amplitude is the absolute value. Remember, that number is 1. The absolute value of 1, which is what? 1. Your amplitude is 1. Your period is 2 pi over, what is k? 1. Which is what? 2 pi. What was that phase shift again? Negative pi over 3. So this is where we're going to start, by the way, right? So, okay. So I got my phase shift now. All right. So the interval of one cycle here. B plus what? Okay. So let's go back here. Remember, what are we going to do now? We're going to do all the work here. We're going to do all this addition. Okay? So negative pi over 3 plus 2 pi. That's the work we have to do here. So maybe I'll just move this all down. And there we go. So divided by 1. So you're going to multiply the top by 3 and the bottom by 3. What do you end up with? Negative pi over 3 plus 6 pi over 3. What does that give you? 5 pi over 3. So your interval of one cycle, ladies and gentlemen, again, let's write that down. What's that interval of one cycle? Negative pi over 3, 5 pi over what? 3. Okay? So there's your arithmetic with that. All right. Okay, that's where you start and then where you end. Okay. And so I'm going to do this here, ladies and gentlemen. Let's give you guys a real, here's going to be a real situation here, okay? If you have to start at that negative pi over 3 and end at 5 pi over 3, this is where you what again? Start, and then here's where you what? End. Where's your amplitude going to be? It was 1. Is that true? So it doesn't have to be to scale. It's just a sketch. I mean, make sure that that is an even amount of space, though. Okay. In other words, if that's this three lines on your paper, make this 3 lines on your paper. Okay. Make it symmetric, but it doesn't have to be 1 line. Okay. It could be any spaced lines because you're just sketching the curve. However, I want you guys to be careful here. Okay, let me go back here. I didn't even sketch that at this point. Whenever it starts with a negative value, like negative pi over 3, I don't sketch the vertical line yet because I don't really know where things are going to end up. I'm not quite sure. So I didn't even do that yet. So we're going to start at negative pi over 3, end at 5 pi over 3. You guys see my point? Okay, now we get to do the what? The arithmetic. Is that true? What's midway between these two numbers? We say negative pi over 3 plus 5 pi over 3 divided by 2. What's that going to give you? 4 pi over 3 divided by 2. 4 pi over 3 divided by 2. 4 pi over 3 times 1/2. And you say, what is that going to be? You can say 4 pi over 6. Is that true? And yes. It'll be 2 pi over 3. And that goes right in here, okay? I'm going to have to move this stuff down. 2 pi over 3, okay? I'm going to erase this. It's in the notes. Let me erase this first. Okay? All right, ladies and gentlemen. We're having to do our arithmetic. This is where all the work is, by the way. We're getting these halfway points, all those halfway points, right? So let's do more arithmetic here. Practice makes what? Perfect. So, okay. Midway between what? Negative pi over 3 plus what? 2 pi over 3 divided by 2. What's that going to give you? Pi over 3 divided by 2, which is pi over 3 times what? 1/2. What does that give you? Good, pi over 6. Yeah, I forgot to do the step. I do the step like this. Okay, I write my division horizontal. Okay, so just to kind of remind you guys, it's always good to know. It always helped me. I just need the next one. You say, what's the next one? Right over here, right? We're going to have to find midway between 2 pi over 3 plus what? 5 pi over 3 divided by 2. Now, what does that give you? 7 pi over 3 divided by 2, which will be 7 pi over 3 divided by 2, which is 7 pi over 3 times 1/2 and gives you 7 pi over 6. Okay, 7 pi over 6. So that goes where? Right on top. All right, you guys okay with this one? Okay, now what I'm going to do here, I'm going to get rid of all of our scratch. If you said, hey, what if I want to go back and see that? It's in Canvas. You guys have that in your notes, and it's in Canvas. You could go back and review. What do you guys think? I wish I had that when I was a student. We didn't have any of this stuff. Okay. Now you say, Mr. Judge, where does that vertical line go? Right? We have the amplitude of 1. Well, you see how this is a negative and a positive number? Just kind of put it between those numbers. It's just a sketch. Okay. So up here would be 1. Remember, we want that. That's the amplitude. Make sure it's even space, okay? It's between the negative and positive number. That's your y-axis. And what kind of curve did they give us? What was that anyway? That was going to be what? Cosine. How does cosine behave? Where does it start? So at negative pi over 3, it actually starts right here. I'm going to move that 1 out of the way, okay? You're over here, 1. Isn't that where cosine starts? And then what does it do? Comes down to the x-intercept value, and then it goes down to the what? The minimum, and then it comes back to the x-intercept value, and then it goes to the what? Back to the maximum value. Is that true? So you guys can now sketch the curve. There you are. You're pretty much done. Because again, you could notate the x-intercepts. You say, what are the x-intercepts? Happens when x is what now? Good. X is pi over 6 and 7 pi over 6. Where is the maximum? The maximum is 1, and that happens for 2x values. What are they? Yep, happens over here, right? And over here. That's the maximum values here. So it's going to be negative pi over 3 and what? 5 pi over 3. What your minimum value is going to be. And where does that happen? Yeah, it happens at 2 pi over 3. Here and where? Here. So this is all the analysis they're going to want you guys to do, because this is the work in your science classes that they care about. This is the information, really. They also care about the curve and the graph, and there's applications here, but you might say, what was this? This was in, I'm going to put this in decimals, okay? Cosine x plus pi over 3. I want to share that with you guys as well in decimals. Y equals cosine x minus pi divided by 3, okay? And compare that to the y equals just cosine curve. Okay? I'm going to change the colors. Come on. Jeez. Take a look. This is the point, okay? Your cosine curve is in blue. And what do you guys notice about that cosine curve in blue? We look at the green curve, that's the phase shift. And I think that, was that plus? Yeah. I think I made a mistake. Wasn't that plus? There we go. So what I'm saying is the cosine curve started where? At negative pi over 3, okay? So if I wanted, and I'm going to do that, I'm going to share with you guys what this looks like, because I want to be complete. Remember, the interval here was from 0 to pi. What was the interval for the new one, the phase shift? We started at negative what? Negative pi divided by 3 less than x. What's the other value? 5 pi over 3. Okay, here's my point. The cosine curve was shifted to the left by pi over 3. And then, hopefully it'll let me what? Doesn't seem to like me touching the what? Doesn't want to. Anyway, let's bring that in. So you guys can see pi over 6, 7 pi over 6, right? The intercepts right here. And then the minimum value is at 2 pi over 3. Is that right in green? Right here? So even in Desmos, we actually have those things. That's the information there. Remember, the x-intercept really is this point, 0, 0. And Desmo just didn't let me touch the maximum and min value for whatever reason. I don't know what it is. Maybe it's my hand. Who knows? But, you know, I want to share with you guys, this is how you handle what? Phase shift. And, yes, do I have a video? Yes, I do. Where's the video? 241. This is called over here. If you guys want to see some more of these examples, it's graphing sine and cosine with what? Phase shift. You can play that video here. And I think 5 hours. You go, Mr. Judge, you can make me watch 5 hours? No. Scroll to where you want to go. Is that right? You guys see what I'm saying? Look at that. Let's go to phase shift. Maybe I have to. Here we go. I don't know. I might actually have to. Here's this. Well, you guys can scroll through and see the examples. Yeah. If you guys want to do the timestamps, you guys are free to do that. What is this called? Graphing sine and cosine, right? So assignment, the phase shift. Graphing sine cosine with phase shift. Okay, and don't you guys have the solutions for the evens? Yeah, I might take a picture of this stuff and give you solutions for the what? Odds and Desmos, okay? Might do it that way. So take care, stay safe, have a wonderful what? Day, ladies and gentlemen.
Thank you.
You're welcome. We got all those people at home looking for the video. So there we go. Okay, so ladies and gentlemen, we were working on graphing sine and cosine yesterday. So here's some of the things that we did. We're going to continue with finding that important piece of information here. Okay, so this is kind of where we left off. We want to determine the amplitude, the period, and the interval of one cycle. And let's continue. Okay, you guys did some of these questions yesterday. So let's go over these solutions. But I'm going to highlight the information we need. So, okay. So going over, the amplitude, the absolute value of -6 is +6. That's my amplitude. Your period being 2 pi over k. Now remember, here's that a value. Here's the k value. So it's 2 pi divided by 1/2. So, ladies and gentlemen, if you need to see it with colors, here we go. But now you're looking at here some what? Some division. So 2 pi divided by 1/2. Okay. 2 pi divided by 1/2 becomes 2 pi times 2 over 1. So our period now is going to be what? 4 pi. So there's the period, ladies and gentlemen. And there you go. There's your period now. Okay, anybody have any questions on this here? Especially the arithmetic portion over here? All right, okay. Well, what's your interval of one cycle now? Remember the definition of your interval of one cycle. It's going to be you start where? At 0, and you end where? At 4 pi. So interval of one cycle, and I'm going to color coordinate this here, and I'm going to remind people when words, we're going to see some of these details. You start here and you what? End there. So that's your interval of one cycle. Okay, now let's continue and finish these here. Okay, so we say amplitude and what? Here's your K value. Anybody have any questions? Anybody have any questions on this here? Nope. Okay. Well, here's A. Here's what? Here's K. So our amplitude, the absolute value of A, which is 4. What's the absolute value of 4? It's 4. Okay, so the absolute value of 4 is 4. Now, our period, 2 pi over K, where K is what? 2 pi. So 2 pi over 2 pi gives you, our period is 1. Okay, all right. Now, interval of one cycle definition. Interval of one cycle is going to be from 0 to 1, and here you go. Okay, anybody have any questions on that one? Is that what you guys got yesterday when we did this here at the end of the lecture? You guys got these answers, hopefully? Okay, good. Now, there you go. Here's your A value, and here's your what? I'm going to color coordinate this K. We're going to talk about this here. A, K, we're going to see how this works. So your amplitude is going to be what? Yeah, it's good. It's the absolute value of negative 2/3, which will be positive 2/3. So, all right, there you go. Period is going to be 2 pi over K, but we're going to have to see what this means. What does that mean? Okay, you say, well, I don't know what K is. What do you guys think K will be? 1/4. K is 1/4. And you say, well, how do you guys know K is 1/4? Because in the format I gave you, K is the number multiplied to X. So you say, but I don't see a number multiplied to X. Okay. X over 4 is 1/4 X. So sometimes students get confused with that one, and I'll remind people that, hey, this is your K is going to be what now? K is 1/4. So you're correct if you said, hey, I think K is 1/4. It is 1/4. So we replace this K with 1/4, and then you're going to do some division. 2 pi divided by 1/4. Okay, so what does that actually mean? You say we have 2 pi here divided by 1/4. Is that right? And then what's division by a fraction? Isn't that multiplication by the reciprocal? So then this becomes really what? 8 pi. So the period is actually what? 8 pi. Okay, so now let's take a look at this. You got your interval of one cycle going to be start at 0 and end where? At 8 pi. So you start at 0 and at 8 pi. So ladies and gentlemen, this is where you start with your graphing what? Career. Okay, you start with your graphing career. Now, I'm going to do some things here. I'm going to remind you guys. I'm going to go to this first one here. So we're going to get all this information. We'll start talking about some detail here. Okay? Take a closer look at this first one. If I said to you, this portion here, that's the interval of one cycle. I'm going to put this in words now. And maybe I'll color it red. So let's focus on this. So here's my interval of one what? Cycle. Interval of what? What does one mean? What do you guys think one means? One cycle. Right? What do you think one cycle means? What curve is this anyway? I read the word what? What kind of curve is that? Sine. Is that true? Okay. So I want to go back here and remind you guys, sine here looks like this. Is that true? I can get a nicer picture. Sine starts on the x-axis, is that right? And then it goes to the what? It goes to a highest point, a maximum. It comes back to the x-axis. It goes to a minimum, and then it comes back to the x-axis. So I'm just going to remind you guys, generally speaking here, just by sketching this, when you think of sine, I want you guys to think of this. And you go, oh, okay. But this is what they call what? One cycle of sine, okay? Because sine is periodic. This is one cycle. So that whole idea behind one cycle is right here. Okay, you guys with me on that? And yes, you're at a what here? You're at a maximum. And here you're at a minimum. Okay? So interval of one cycle. Now, if I go back to Desmos and say, well, how does sine really look again? Generally speaking, any sine curve, okay, Desmos, right up here, we did that. I'm going to do it like here. I'm going to change that color. And you're kind of looking at sine in general. I guess I'm going to kind of tweak this a little bit. Well, here's sine in general. What you're looking at is what's called infinitely many cycles. Infinitely many cycles, because that goes on forever. I could say, hey, let's take a look. Let's go to the right. Well, that goes on forever, doesn't it? Let's go to the left. Doesn't that go on forever? So sine is what's called periodic, and there's infinitely many cycles. The second I restrict my domain, like I do up here, this is only one cycle now. Okay, you go, what do you mean by one cycle? Well, you start at the minimum, which is really on the x-axis. I'm sorry. Start at the x-axis. You get to the maximum value. You get to the what? The x-axis again. So all these are x-axis. Now, the minimum value, and then you're back on the x-axis. This is one cycle of what? Of sine. So that's the general picture. In a lot of these graphs, they only want you to draw one cycle. However, look at the details here. If I said to you, what are the x-intercepts again? X-intercepts are where your curve crosses the x-axis. Is that right? It's where your curve crosses the x-axis. So you cross the x-axis where? At 0, at pi, and at what? 2 pi. Zero, pi, and 2 pi. So if you said, okay, over here, I want to label this 0, pi, and what? 2 pi. Those are my x-intercept values. So you may want to summarize it, because I do. You're going to say x equals 0, x equals pi, and x equals 2 pi. Those are your x what? Intercepts. Now, they're going to ask you as well, at what value of x do you get the maximum value? Well, this is where we're going to start to talk about some arithmetic skills, ladies and gentlemen. Because where you get to the maximum value is going to be what? A number midway between 0 and what? And pi. Okay, you guys okay with that? It's a number midway. So you might say, how do I find numbers midway? What's midway? I'm going to have to look at my website, because I know I did a few things here. Midway. Okay. So this is where you get some of the S in this course. And you go, oh, Mr. Judge, how do I get that number midway? What are you even talking about? Oh, this is where we're going to transition. If I can get here. 241. Midway. And I thought, no, maybe not. Let's see if I can find what I'm looking for. Yeah, okay. So here's going to be our big question here for this. What number is midway between 0 and what? Pi. Okay, we're going to find a number that's midway. Now, I'm going to give you what's called a midway formula. Okay? Do you guys happen to know, if I said to you, this, you have two numbers. I'm going to put it in purple. What number is midway between A and what? B. This is the midway formula. What number is midway? Do you guys know how you find midway numbers? Anybody know? What do you guys know? Yes.
Isn't it A plus B divided by 2?
Yep. That's it. In other words, you add, I'm going to put this formula here for you guys this way. You add the two numbers, and then you what? Divide by 2. Okay, so you're going to add the numbers and you divide by 2. So in this case now, you might say, do I take the 0 and do I take pi? Do I add them and divide by 2? Well, yes. So you take 0 plus what? Pi, and you divide by what? 2. What is 0 plus pi? Pi, and you divide by what? 2. Now, ladies and gentlemen, there you go. It's pi over 2. So that number goes where? Over what? Here. Easy peasy lemon squeezy. Alrighty. Now, let's do this again. Now, this is for the curve for sine in general. We deviated from this question, just so you know, but I have to deviate. I got to deviate. Okay, where do you get the minimum value then? Okay, because what I put in the notes is the maximum value is positive 1, and that happens when x is pi over what? 2. So I get the maximum value is 1, and it happens when x is pi over 2. So how do we repeat the process and get the minimum value? How do we do that, ladies and gentlemen? What do we do? Again, what do we need? A number that's midway between pi and what? And 2 pi. So midway between pi and what? 2 pi. So how do you guys get that? Let's do another calculation. Pi plus what? Plus 2 pi, some arithmetic, divided by 2. What do you guys get? What's midway now? That's going to be what? 3 pi over 2. Is that true? And there it is, 3 pi over 2. So this answer is 3 pi over what? 2. So you say, Mr. Judge, what does that mean? Well, the minimum value is negative 1, and it happens for x being 3 pi over 2. That's what this means. So here's what you guys get. Max is 1, min is negative 1. And that's kind of what they're going to look for. These are the essential questions they're going to ask you. Now, this is really over just the curve y is sine for the interval of one cycle that starts at 0 and ends at 2 pi. Okay? That's the whole idea behind this phrase, interval of one cycle. So I have to step out and go, hey, what are they even talking about? That's what they're talking about, all this gory detail. So there's some arithmetic. Go to Desmos, right? In Desmos, you might say, is that what they're doing? Yeah, look at this highest point, right? Highest point happens at pi over 2. The value's positive 1. Lowest point happens at 3 pi over 2. The value's negative 1. So, ladies and gentlemen, there it is. That's what we're looking for. So go back to the original question. You might say, what does all this information mean when I have to graph y as 1/4 sine pi x? Well, okay. What's your interval of one cycle? What is it? 0 to what? To 2. Okay, so you're going to start with the interval of one cycle from 0 to 2. So where would 0 be? Right here, is that right? And where would 2 be? Well, maybe somewhere over here. Is that true? So you start here, and you end where? Over there. Is that right? You guys with me on that? So, and we're graphing what curve? Isn't this sine? So, I mean, that's my point to you. You have to know what that curve is. Now, somewhere over here is midway. Somewhere over here is another midway. In other words, you partition this line into how many regions? 4 regions. So we're going to start by getting that midway number between 0 and 2. So this is what you start. You start with that interval of one cycle. Is that right? So your interval of one cycle here is from 0 to 2. So could you guys tell me in red what's halfway between 0 and what? 2. How do you get halfway between 0 and 2? 0 plus 2 divided by 2. Isn't that 2 over 2, which is? Isn't that 1? Is that halfway? Good, good. These are where my what lives. You guys remember? This is where my intercepts are. So if I sketch this curve going here, going down here, right? I have the maximum value. I got the minimum value. I have essentially the sketch of sine that we're looking for. I know my sketch isn't that nice, but that's okay. There we go. The question now is going to be this point and this point. So what is midway between now 0 and 1? Do you guys know? What's midway between 0 and 1? Is it 1/2? How do you know? You guys know? You do some arithmetic. 0 plus 1 divided by 2. What is that going to be? This is 1/2, isn't it? Easy peasy. Is that 1/2? What's midway between 1 and 2? 1 plus 2 divided by what? 2. What do you get? You get what? 3/2. So there you go. So you start with the interval of one cycle, ladies and gentlemen, and you find all these halfway points. Yes, it's using arithmetic, okay? But what's your amplitude going to be now? What's the highest point? Do you guys remember what the amplitude was over here in this original question? What's the amplitude? Okay, what does that mean if the amplitude is 1/4? The highest point is 1/4. Good. And it also means the lowest point is what? Yep. So guess what you guys just did? This is the x and y axis. What have you guys just done? This is y equals what? 1/4 sine of what? Pi x. So, I'm going to get rid of our arithmetic, but the point I'm making is there is arithmetic in trigonometry. Remember, it's a process that involves arithmetic. Let's get rid of this here. Okay, you guys okay with that one? Easy peasy lemon squeezy? What do you think? Easy peasy lemon squeezy. So, but the devil's in the details, meaning you got to do more than one problem, but this is how you go about graphing sine. Okay, you guys okay with that one? And I'm going to look at some more here.
What about x-intercept?
Oh, let's summarize this. X-intercept, where do you have x-intercepts? Where your curve hits the what? X-axis. So let's do our summary here, because I remember when I wrote those things, I asked people, where is your x-intercept values going to be?
Yeah.
Where are they? At x equals what? 0. X equals what? 1. And x equals what? 2. Okay. Where do you have the maximum values of the function? That happens when x equals what? What is the max? Do you guys know what the max is? It's 1/4. Good. Where do you have the minimum value of the function? Where's the min? X equals what? 3/2. What's that min going to be? Negative 1/4. So you have all of this analysis. This is the question I've asked people on those worksheets. Okay, so I even want to know, can you guys, find these values? Because sometimes what students do, they don't care about those numerical values. They don't do the arithmetic. But you got to do arithmetic, because how are you going to apply what you've learned if you don't, draw the details? Right? This has applications, and all the applications really have to do with what I'm summarizing here. So when I made that worksheet for you guys, that's essentially what I was doing. This is all the detail that they're going to, ask you in your life about the applications that come from a graph of a sine curve and a cosine. This is what it is. So anyway, ladies and gentlemen, that's all the gory details. Gory details. Okay, good. Let's do another one here, okay? And I'm going to do this here for you guys. I'm going to take really this question here, y equals 6. I'm going to look at this graph here. Okay? I'm going to look at this information because we already have this information. Now, this is a different question, but what I'm going to do here is this. I'm going to note this here. There's a very good reason. I'm going to note. You're going to look at y equals positive 6, not negative 6, sine 1/2 x. Okay? So notice the difference with what I'm doing here. There's a very good reason. Okay? There's a very good reason. It has the same information. In other words, the amplitude is still going to be 6. Your period is 4 pi. The interval of one cycle is 0 to what? 4 pi. Okay, all that information. Now, where do you guys start again when you start to graph this thing? Do you guys remember where you start? You're going to draw your x and y axis. All right. And you always start with the interval of what? This is my interval of how many cycles? 1 cycle. What's the interval? 0 to what? 4 pi. Easy peasy lemon squeezy. Okay. And if I were you, I'd draw this framework that you guys seeing here. The halfway mark over here. Halfway to halfway, and these other halfways. So what you're really looking at is that this is a sine curve. Here it is, sine. And this is where you'll have the maximum value. This is 1 cycle. This is where you have the minimum value. Zero, 4 pi. Could you guys tell me what's halfway between 0 and 4 pi? What's midway? We're saying midway. How do you guys find the midway value here? Anybody know? How do you get midway? What's the formula? 0 plus what? Divided by 2. What do you guys get? Isn't that 4 pi divided by 2, which equals what? 2 pi. Easy peasy lemon squeezy. Alrighty, what about this value and this value? How do we get those midways? What's midway here? 0 plus 2 pi divided by 2. What does that give you? 2 pi divided by 2 is what? It's going to be pi. So this is going to be pi. Easy peasy lemon squeezy. Alrighty. What about this midway over here? 2 pi and 4 pi. What's midway over here? Well, you're going to say what? What's 2 pi plus 4 pi? 6 pi over 2, which gives you what? 3 pi. What about the amplitude? What do we say the highest value would be? What is that, ladies and gentlemen? Isn't that going to be what? 6 and -6. Is that true? So here's my graph. All right, you guys okay with that? There it is. That's your process. Okay? Now, if they ask you, let me erase this here. If they ask you this question here, ladies and gentlemen, they're going to say, what is the x-intercepts What do you guys tell me? Take a look at the curve. Where are your x-intercepts? X equals what? X equals what? And x equals what? What's the maximum value? That's your amplitude. It's what? 6. Good. Where does it happen? X equals pi. Is that true? Right here. This is that maximum value right in here. So you want the summary too. There's your maximum value. Where's the minimum value? Minimum is -6. Is that right? And that happens when x is what? 3 pi over 2. Now again, you're going to say, Mr. Judge, why do you care about all those details? Because for the application questions, they really pretty much, they want to know that information. That's why I asked you in the worksheet here. Anybody take a look at the worksheet about graphing? Did you see those kind of questions? You don't want to wait till the night before, right? Night before a test. I don't know. I can't see. Maybe. You see some of those? Yeah. What do you guys think? Does that look okay? You guys see how I put that there for you? Yes.
It's 3 pi instead of 3 pi.
Oh, 3 pi. Sorry. Thank you. Thank you. I get caught up with this. Sorry. Okay. All right. You guys okay with that? That's the graph of y equals 6. Now, you said, but Mr. Judge, what happens with that -6? Okay. What about this? -6. Well, let me do this here in Desmos here, okay? Yeah. What's the effect of a negative here? Y equals -6 sine one half what? X. And I guess I have to do this 0 to... What was the interval of one cycle? Was it 4 pi? Okay, so we're going to say 0 less than or equal to x less than or equal to 4 pi here. And I'm going to have to, you know, fix whatever this is. The x-axis will be -1 to 12. Okay, you guys okay with that? Now, I'm going to color coordinate this so you guys compare and contrast. This is going to be red. So you guys see this graph negative? And you go, oh, that's what it is in red. What do we just get through graphing, though? Can I copy this? No, I guess not. It's weird. Y equals +6 sine again. Okay. It's really weird. Let's compare and contrast. So in green, what are you guys looking at? Positive 6. Is that true? In red, what are you looking at? Negative 6. What's the difference between the curves? They are both reflected about what axis? The x-axis. Is that true? What do I mean by being reflected? So here's what I'm saying to you guys. This is the positive graph being reflected about the x-axis. If I put a mirror down here and I reflect that blue curve about the x-axis, what do you guys think I get? Anybody know? What do I get down here? This is the negative curve. Okay, this is being reflected about the x-axis. So you might say, what's my strategy, Mr. Judge, if I get a curve that has a negative a value? Here's the strategy. Graph the positive and then do what? Reflect it about the what? The x-axis. However, that's going to change some of these answers. Not every answer. In other words, your minimum now and maximum has switched places. Is that true? Right? So your minimum is going to be negative 6 still. And then that happens at what now? That happens at x is pi. The maximum is going to be where? Maximum is going to be 6 and happens at 3 pi. So those things change because you have a reflected about the x-axis. That's that negative sine curve. Easy peasy lemon squeezy. So you always want to remember that if it's a negative value. All right, good. Let's have you guys try one. You guys ready? I want you to find all those things here. I'm going to look at what we see here. I'm going to put this as a negative. You're going to find all those things we talked about, and you're going to sketch that curve. Okay, you're going to try that out. Let's get the clock out, and we'll see how this goes. All right, lucky 8. Okay, thank you, thank you. So remember, you might get concerned because you see this negative A value. Is that right? So your A value, your K value, that's negative. So in your mind, I would say, yes, find all that information. The amplitude, well, here's what I can say to you. Graph what? Y equals 3 sine 2x. You graph the positive, it's going to have the same amplitude and all the other information, period, and so on. So you can go about it this way, where your amplitude, again, is going to be the absolute value of 3, which is 3. Is that right? And let's get the period. Two pi over, what's the K value? 2. Okay, so what is, the 2's cancel? So your period is going to be what? Pi, is that right? Okay, what's your interval of one cycle now going to be? What's that interval in one cycle? 0 to what? Pi. Okay, you guys okay with that? Now, that should tell you something. You say, what does this tell you? Right? You start where? Where do you guys start with this? You start at 0, and where do you end? Pi, right? This is where you start, and this is where you end. Is that true? That's why you got the interval of one cycle. Okay, and then now, what do you guys do? You need the halfway mark, and then the other two halfway marks, okay? But this, again, is what curve? It's the sine curve. So you go up to the max, get down to the intercepts, minimum value back at the x-axis, okay? So here's your x-axis, and here's your y-axis. There we go.
So is the arc determined by the amp?
Excuse me?
So like say it's the amp 3 and -3, that's how long the arc should go?
Well, the amplitude being 3 means that the largest value is 3. And similarly, the smallest value will be what? -3. This is the meaning of your amplitude. That's the maximum value. It's like the altitude here. Okay, how tall that is, 3. So that's what that means. Okay, that's your amplitude. Right? But we're plotting the x-intercept. So now you have to do the halfway. What's halfway between 0 and pi? Now, sometimes some students are going to say, you know what, Mr. Judge, I don't even know. It is pi over 2. 0 plus pi divided by 2 gives you what? It's pi over 2. Okay? And what's the maximum values? Right? It's going to be 3, but you're going to have to now also give me what's midway between 0 and pi over 2. So what do you think that's going to be? Is it pi over 4? How do you guys know that's pi over 4? Okay, because you do this 0 plus what? Pi over 2 divided by what? 2. So that will be pi over 2 divided by 2 And then you write it down as pi over 2 divided by 2. Which is going to be pi over 2 times 1/2. And you end up getting pi over what? 4. There it is. Yes?
Wouldn't the graph be opposite?
It will be, but we're not done. It will be. Okay, now what's this next value going to be here? Right, this is going to be, ladies and gentlemen, more arithmetic. You go, oh my God, this is where the S comes in. You go, okay, what's the S? You take pi over 2, you add it with the pi, and now you divide by 2. Okay, you guys see what we're trying to do? You're trying to find the midway again. So tell me with this now, what in the world, how do we find those midways? All right, how do I add pi over 2 with pi? You guys might know how to do that because you've been kind of doing this already. Anybody remember? How do you do that here? This is going to be over 1. So what do you end up doing? What's it going to be? Times 2 times 2. Is that right? Okay, do you guys remember that? You're going to use that 2 down there. So what do you end up with? This is going to be really, let's do the arithmetic here. Pi plus what? 2 pi over 2 divided by 2. And what does that numerator give you? What's pi plus 2 pi? This is 3 pi over 2 divided by 2. And you're going to get what? 3 pi over 2 divided by 2, which will be what? 3 pi over 2 times 1/2. And that gives you 3 pi over what? 4. There you go, 3 pi over 4. So, ladies and gentlemen, there's your answer. This is your arithmetic. Right? Right in here. So, okay, now you might say, but that's not what they gave me. Why am I looking at positive when they gave me what? The negative value. Okay. Well, what do you guys remember? Aren't they all reflected what? Go back to Desmos. Aren't they reflected about the what? X-axis? They sure are. So what that means now, ladies and gentlemen, is you're really going to have this curve here. Okay? You start at 0, you get the minimum, go back to the x-axis, you get the maximum, you're back to the x-axis, and now, ladies and gentlemen, here you go. That's the curve they're talking about. Now, maybe we want that curve in red. I don't know. So, just in honor of Desmos, this is the negative sine curve. And ladies and gentlemen, we are now ready to perform our analysis, our conclusion here. And there it is. Okay, so here's our conclusion. X-intercepts. Where do they happen? X is 0. X is pi over 2. X is pi. Is that true? You guys okay with that? What's your minimum again? It's -3. That happens when X is what now? right? Pi over 4. You guys see what I'm saying? You're saying, you're over here. Yes, that's pi over 4. And the maximum value is positive 3. That's the amplitude. That's what we're saying here. That's why you got the amplitude. But you're standing way up here. So that happens at what? 3 pi over 4. Minimum is negative 3. Maximum is positive 3. And again, you care about these x-intercept values. So there you go. There it is, ladies and gentlemen. Easy peasy what? Lemon squeezy. There it is. Y is negative 3 cosine 2x. Now, if we go back here with some of the work we did earlier, and try to copy this, to compare and contrast about cosine. Cosine is very similar now. I won't go to the exact same idea, but I want you guys to understand this idea here. I guess this is now going to be what? Cosine. So you might say, how does this all work with the cosine curve? Okay, so again, you already found this earlier. What's your interval of one cycle? Right there. You start at 0 and you end where? At 1. So you start at 0 and you end at 1. Okay, now you're going to again need another halfway point and then halfway between halfways. But I'm going to remind you here the amplitude is 4, so the maximum value is 4 and the minimum is negative 4. Is that true? So notice the schematic here that we're putting together, right? Is that so far so good? Amplitude is what? 4, highest value. Now, I want to remind you guys something here. This is a different curve. What curve is this? This is cosine. So how does cosine behave? Do you guys remember how cosine behaves? Cosine starts at the what? At the maximum value. Is that true? Cosine starts at the maximum value. It goes to the x-intercept, and then it goes to the minimum value. It goes back to the x-intercept, and then it goes back to the what? Maximum value. So essentially, there you go. Because this is, again, the cosine curve. All right. Okay. So I want to make sure you guys know here we need that first value that's midway between 0 and 1. So what is midway between 0 and 1? How do you find that? You take 0, you add 1, you divide by 2. Isn't that the midway formula we talked about? And then that, doesn't that give you 1/2? Because 0 plus 1 is 1. There's 1/2. Now, what's midway between 0 and 1/2? What do? You say 0 plus 1/2 divided by 2. 0 plus 1/2 is 1/2 divided by 2. We'll put it down here. Which is 1/2 times 1/2, which will be 1 what? 4th. So this value is going to be what? 1/4. What's midway between 1/2 and 1 now? If I said to you, 1/2 and 1, what's midway? Oops. Okay, I'm going to get rid of that. How do you do that arithmetic? Okay, let's do that arithmetic right here. 1/2 and 1. So midway, we're going to say 1/2 plus 1 divided by 2. And how do I take 1/2 plus 1? Right? How do I add that with 1? Do you guys remember? You replace 1 with what? 2 over 2. Isn't that 1? 2 divided by 2? They now have the same exact denominator. So you get 1 plus 2 over, here's what you end up with. 1 plus 2 over 2 divided by 2. 3/2 divided by 2, which will be what? Which is 3/4. There it is, 3/4. This is arithmetic, ladies and gentlemen, with fractions here. So, okay, we're now ready for what? We're now ready for the analysis, aren't we? Okay. X what? Intercepts happen. Where do your x-intercepts happen? Here and where? This is where you cross the x-axis. So where do you cross the x-axis? Right, you cross where? At x equals what? 1/4, and x equals what? 3/4. The maximum value of the function is where? 4. Okay, where, for what values of x does it equal 4? At 0 and what? 1. So that happens when x is 0 and x is 1. Do you guys agree with that? What about the minimum value? The minimum value is -4. Where does that happen? Yeah, it happens when x is what? 1/2. Right there. So, ladies and gentlemen, what I'm suggesting to you guys here is this. You do need to know what curve you're sketching. Is that right? And even if you have a negative cosine, it works exactly the same way. So, you know, if you guys want to even double check, I know what I did here for your homework. Did I do some solutions there too? Did you guys notice that? I think I'm looking back at the website. It's in Canvas, but I even did some solutions here for you. Double check. Well, I got video solutions, but you also have here, yeah, we had the homework there. So anyway, I don't really like how this is. I'm going to have to somehow figure out how to change it. Yeah, let me see what I have. Oh, I got answers as well. Good. On the worksheet, I do have answers. You guys see that there? Is that right? Yeah, just for the even. So maybe you guys want to do, I think I did you know why I did the even answers? Do you guys know why? The video has the odds. Oh my God. The video has the odd numbered questions and this has the evens. You guys have all the answers. Although don't copy this and turn it in for your homework. You guys want to do what? Try this out yourself. All right, ladies and gentlemen, take care. We'll see you guys tomorrow. Here we go. So how did you guys apply the fact that cosine is even? What does this mean? Do you guys know? It means y is cosine of what? X over 3. Okay, is that what it means? So it kind of means just ignore the negative sign. Okay, now we have to find the what again? We got to find all these things that we've been finding. The amplitude, the period, the interval of one cycle. So what is the amplitude here? If it just says cosine, what's your amplitude? 1. So, okay, get your highlighter there because this is what? That's your A value. Is that true? And then what is K? Do you guys know? So let's take a look here. We're going to have to look at some details. You see how it says x over 3? What does that even mean? Doesn't that mean this is 1/3 times x? Is that what it means? So what is k? K is 1/3. Is that true? All right. So, okay. So, ladies and gentlemen, if we're going to find the amplitude, it's the absolute value of 1, which is 1. Is that right? And if we're going to find the period is 2 pi. What's k? 1/3. Two pi divided by what? 1/3, and that's going to be. Let's do the arithmetic here. Okay, this is what? 2 pi times 3 over 1, which is going to be what? 6 pi. So, ladies and gentlemen, the period is 6 pi here. Okay, is that true? Okay, what's your interval of one cycle then? Remember, you start at 0 and you end at the period, 6 pi. Okay, so I want you guys to really note that again. And if you need to put start, and they call this interval of one cycle because it's only going to be one cycle. And ladies and gentlemen, there we go. Okay, we have all the information to start. Does anybody have any questions? Okay, is that what you guys wrote down here? Good, good. All right. Okay, so ladies and gentlemen, you're going to start where? At 0. You're going to end where? 6 pi. Can I ask you guys, what kind of curve is this? It's cosine. How does a curve for cosine behave? You start at the top. The amplitude was 1. So you start over here. Is that true? This is where you start. So when x is 0, you're starting at the amplitude, the maximum value, because your curve is a cosine curve. And that's how cosine behaves. So you got to know how that behaves. Okay. Now you say, well, what happens with that curve? Well, you start at 1. And yes, that's where you start. You start at 0, right? I'll put 6 pi over here, ladies and gentlemen. And since it's cosine, don't you end at the maximum value as well? Because it's a cosine curve? Okay. So if I were you, I'd start writing down the halfway points. Is that right? Halfway, halfway, halfway. Because for cosine again, you're going to go to this first point. It's an x-intercept, and I put it in red. It's on the x-axis. This is cosine. And then it goes to the minimum value. Is that true? Then it goes back up to the x-axis, and it's back. So ladies and gentlemen, here we go. There it is. This is a sketch of the what? Of your cosine curve, and this is going to be a -1 value. So far, you sketch the curve. However, I'm always going to ask you for these special locations. And you go, oh, I got to get all these locations. Now, what did you guys learn yesterday? How do you do that? Right? Yeah, you're going to have to find the midway points. So you're going to have to do some arithmetic here. 0 plus 6 pi divided by 2. And what's 0 plus anything? 6 pi divided by 2 is going to be what? 3 pi. So this here is 3 pi. Now, what's midway between 0 and 3 pi? What do? Don't you add? Divide by 2. What's 0 plus 3 pi? This is now 3 pi over 2. So, ladies and gentlemen, that goes right here. Is that true? Easy peasy lemon squeezy? No, you leave it like this. Symbolic answer. Ladies and gentlemen, symbolic numbers are fine. All right, you guys okay with that? Easy peasy? Probably the hard one. Let me erase some of this here for you. The hard one for people probably is right over here. What is 3 pi plus 6 pi? Right? 3 pi plus 6 pi divided by 2. What's that going to give you? 9 pi over 2. So you're going to have what? 9 pi divided by 2. And there you go, ladies and gentlemen. Can I leave my answer symbolically as 9 pi over 2 for that point? The answer is yes. So remember the questions I usually ask as well. I want you guys to note here. What you need to know is where are the x-intercept values? Okay? What are the x-intercepts? They happen at two locations. An x-intercept is where your curve hits the x-axis. They're in red. It happens when x is what? 3 pi over 2, and when x is what? 9 pi over 2. Is that true? These are the red points. And there it is, ladies and gentlemen. The maximum value of the curve, where are you at the highest altitude if you're walking on this curve? Don't you start at the highest? So the maximum, if you guys remember the definition, is the amplitude. And that happens for what values of x? Do you guys know? Yeah, for x equals what? 0 and x equals 6 pi. It happens for these values here. When x is 0, x is 6 pi. You're at the maximum values here. So where are you at the minimum values? Anybody know? Where are you at the minimum? Where are you at the valley here? Because I would say to you, if I find the right color here, maybe gold. Over here, your cosine curve is between -1 and +1. What that means is you're in a valley here when x is 3 pi. You're in a valley. You're at the lowest value. The minimum value is -1. And that happens when x is what? 3 pi. So, ladies and gentlemen, this is why you care about that information that we're looking at here. Easy peasy lemon what? Lemon squeezy, is that right? What do you guys think? Is that okay? Yes.
Why not list it as -3 pi?
-3 pi. Well, what do you mean for the minimum?
Yeah.
The minimum value is a y value. A minimum value and maximum value is on the y-axis. So if I color, this is an altitude. Like think of it, remember this is sea level on the x-axis. So when they say what's the maximum value, they're saying if these are hills, the maximum altitude is at 1. Okay, and you're at 1 for these values of x, when x is 0 and x is 6 pi. You're at a minimum right over here, and the minimum is -1. You're below sea level. So the minimum value is -1. So you never multiply -1 and 3 pi at all. You don't multiply that. These are actually addresses. This is, again, the y-coordinate value, if I want to put it there like that. This is your y-coordinate value for both. And you might say, oh, are these addresses? Yeah, this is the address. X is 0, y is 1. This is the formal address. X is 3 pi over 2. Sorry. Yeah, x is 3 pi over 2. Y is 0. And this is a formal address down here. That would be x is going to be 3 pi. Y is -1. And then here, x is 9 pi over 2. Y is 0. And then finally, x is 6 pi. And y is +1. So it's always the y-coordinate That's the maximum. Okay. And then even you say, what about the x-intercepts? Well, the x-intercepts happen where y is 0. And these are all the x values for which they happen. You know, so you're looking at the addresses, so it's a y coordinate value there. So you don't multiply those, but anyway. All right, now go to number 2. Anybody have any questions on that? This is all the detail, ladies and gentlemen, all the gory what detail. Ooh, you like the detail? The devil's in the details, is that right? Devil's in the details. Ooh. Details. Cosine. Here we go, ladies and gentlemen. What is the value of A and K? You guys see what I'm going on here? A is -2 and K is 3. Okay, so your amplitude is the absolute value of A, which is the absolute value of -2, which is 2. Sorry. So if you guys had that earlier, you guys are correct. Your period is 2 pi over K. What's the K value? Anybody know what K value is? It's 3 here? Now, can I simplify this fraction, 2 pi over 3? No. So what do you guys notice? That's the period. Period is 2 pi over what? 3, is that right? What's your interval of one cycle now? You start at what? 0, and you end where? 2 pi over 3. Start at 0 and 2 pi over 3. All right, okay. Well, you have to simplify your fraction. You say, Mr. Judge, do I write that as a decimal? No, you simplify your fraction. But does that 2 cancel with 3 in any way? Can I simplify 2/3? Nope. You're done. So that's really 2 pi over 3. You leave it like that. This is symbolic. Now, the thing about it is you're going to use the amplitude again. And you might say, you know, Mr. Judge, you're always using, this is not to scale, by the way. Right? Do you guys agree with me on that? It's not really to scale. I mean, what do I mean by that? Well, cosine, ladies and gentlemen. This is the cosine curve. However, if you are awake, is anybody awake? What do I mean by being awake? What do you guys notice about A? It's negative. What does that mean then? Do you start at the maximum or do you start at the minimum? Good. You really start where? Down here at -2. Is that true? Well, what is your A value? A is negative. So, I mean, you could go about it two ways. You can graph cosine and then, reflect the curve. Maybe you said, no, I'm going to do what, Mr. Judge? I'm going to first graph what? And in the video, I actually teach it that way. I say to students, hey, if you're used to graphing this first, go ahead, but you're going to ultimately reflect it about what? The x-axis. So I don't mind, but just don't forget it's going to be the reflection on the x-axis, right? So if you said, I want to approach it the way you did in your videos, okay, here's cosine. That happens when x is 0, is that right? And then if we go to the maximum value again, or at least the period is what? 2 pi over what? 3. Over here, you're going to get now the maximum again. That's what I was talking about. So you might say, I want to graph cosine and then reflect it. You still need what? The midway values. Is that right? Because the cosine curve goes to an x-intercept here and here, and it goes to the minimum value here. And so you're going to think of it that way. But don't forget, you're going to ultimately what? Reflect. You might even say, Mr. Judge, what do you mean I'm going to reflect? You're going to reflect this curve because this is positive cosine. This is in blue. But the A value is negative, and that means you have to what? Reflect that curve here. So I don't know what color you guys want to use for that reflection. I was using red yesterday. So these points are all going to be what? Reflected here. Your mirror is going to go where? Down here. And then your curve, your what? Curve. This is the negative cosine because A right in here is negative, okay? A is negative. So you might say, well, which one do I use, the blue or the red? It's the red. Yep. So what's midway between 0 and 2 pi over 3? 0 plus 2 pi over 3 divided by what? By 2. What's 0 plus 2 pi over 3? 2 pi over 3 divided by 2. Aren't you doing the same arithmetic? This is the portion, in all honesty, that I think people need the most work with. How to add, ironically, the arithmetic, right? And then what does that mean to have 2 pi over 3 divided by 2? What does that mean? Do you guys remember? 2 pi over 3 divided by 2, which is 2 pi over 3 times what? Doesn't the 2 cancel? And then you're left with what? That's just pi over 3. Is that true? So this is where people probably, from my experience with the class, trig class, is arithmetic. Well, you do multiply across, right? Isn't this 2 pi, double check here? You say, is that 2 pi times 1 over 3 times 2? It is. And 2 pi over, I'm not even going to multiply. I'm going to get rid of that. And again, this is every detail. That's what you're looking for. Pi over 3. It goes right here. Easy peasy lemon what? Lemon squeezy. Pi over 3. Okay, now what about the next portion, ladies and gentlemen? How do we find the midway portion here? 0 plus what? Pi over 3 divided by 2. Is that true? We need midway there now, right? And what is 0 plus anything? Itself, pi over 3 divided by 2. And then that's pi over 3 times 1/2. And what is this? Is that pi over what? 6. So here we go, ladies and gentlemen, pi over 6. We're going to place that over where? Over here.
It always throws me off at the bottom number being the small number.
That's what?
It always throws me off that the bottom number is bigger than the top.
Bottom is bigger. Pi over 6. Okay, because this is how we add, multiply fractions here. So I might try to take a look in my videos, see if I have arithmetic with fractions. I think I do. Arithmetic with fractions, right? How to multiply fractions and simplify fractions. Okay, what about the next one over here? What do you get here? All right, pi over 3 now, plus 2 pi over 3, is that right? And divided by 2. What does that give you now? Do you guys know? So what's this going to be? Pi over 3 plus 2 pi over 3 gives you what? 3 pi over 3 divided by 2. What happens with your 3's? And then what does this equal? Good. There you go, ladies and gentlemen. It's in the arithmetic. This is pi over what? 2. And there you go. You got all the information you guys need here to graph this. We just have to do the analysis, right? Did you guys get this in your notes? We have to do the analysis because the analysis is really what they really care about at the end of the day when you start working with applications. So can I erase this here? Hope our video doesn't get flagged from YouTube, right? All right. Let's do the analysis. Let's see. Oh, do we have everything okay? What do we want to find? X what? Intercepts. So remember, the x-intercept is really the definition is the x-coordinate is some value, and then you have a y-coordinate is always 0. That's what we mean about the x-intercepts. So we're looking for those x values here, right? So what are they? Happens at pi over 6 and pi over 2. Is that right? So x is what? Pi over 6, and then x will be pi over what? 2. Those are your x-intercepts. Now, again, where is your what again? Maximum value. The maximum value, where's the maximum? Think of it as altitude. Where are you? You're on top of the what? Hill. Maximum value equals what? 2. And where does that happen at? Right? This is the address again. X is pi over 3 and y is what? 2. It happens for what x value? Pi over what? 3. Is that right? Do you guys remember how to plot points? Okay, now what about the minimum? Doesn't it have 2 minimum values? Where are the minimum values? Here and where? Here. The minimum values are what? -2. That happens when x is, what's the address? Right? If I said to you, what's the address of this location? Right? X will be 0 and y is -2. Is that right? So that happens when x equals what? 0. It also happens when x is, what's the address over here? Right? X here. What's this x? X is 2 pi over 3 and y is -2. So it has a minimum value, again, here. Okay, let's put the right colors. Happens when x will be these numbers here, 0 and 2 pi over 3. So I want to kind of point that out if it makes some sense to people. The maximum value is always the what? Y value, and the minimum value is always the y value. So they're both what? Y values. Y equals and y what equals. There it is, ladies and gentlemen, there it is. Easy peasy, lemon what? Squeezy. Now, you might say, Mr. Judge, you taught